questions here that, oh, I was going to say one thing about black holes and other things. I mean, one thing that I have to say I first wondered about when I was a quite young kid is, are particles actually just black holes? And we're getting closer and closer to that conclusion that in some sense, particles like electrons and so on, which in our models are features of space, we imagine them to be some kind of topologically stable feature of space. But I think, the relationship between what's a black hole, what has an event horizon, what counts as a topological feature of space, I'm not sure, maybe Jonathan has some words of wisdom about that connection, but I think that there's an increasing it's increasingly looking as if the kind of lump of weird stuff in space versus black hole are at least a very similar story.
Right. I agree. That does seem like a plausible hypothesis. I mean, for me, the interesting question is, if it's the case that the description of a black hole singularity and the description of a topological obstruction that is an element that we interpret as an elementary particle, it could well be that those descriptions are actually very similar. But the interesting question, I guess, would be, in the elementary particle case, do they end up being naked singularities, or do they obey? Is there an event horizon of particles? And if so, what does that really mean? What are the sort of implications of that for things like particle interactions?
Well, I think yes, but my belief about that would be it's the same kind of no hair story as black holes. That is, the fact that all electrons appear to be the same might be the same reason that all Schwarzschild black holes appear to be the same. That is that an electron, it could be the case that every electron might have its own personal story, but it's inside its event horizon. I mean, that's its own personal way to attach to the main part of the hypergraph, but it's inside its event horizon. And so, with respect to every external property of the electron, it has only a definite form. I think that's that's kind of the intuitive idea. But really, one of the things that I would say we've been remiss in doing, we haven't done yet, is really go on a hunt for particles. We've kind of been waiting. There are a few things that we're trying to do in preparation for the hunt for particles, which is the hunt for topologically stable structures in hypergraphs and so on. One is Max Piskanoff's work on local multi-way systems, which has been going rather well, and where the idea is that you're able, so one of the things that I'm keen on is this concept of multi-space, this combination of physical space with branchial space, where what we've been doing so far is mostly talking about global multi-way systems. That is, this is the multi-way system where every node in the multi-way graph is a whole state of the universe. The idea of a local multi-way system is that you get to kind of weave together only those parts, the things that are sort of common to different states of the universe are all together, and it's only kind of bubbling out in the direction of things that are not common. And that's this concept of multi-space. And we've been trying to sort of start understanding multi-space. And it's just a very challenging thing to wrap one's head around or to visualize and so on. But that's one thing is the development of local multi-way systems. Another thing is that we've been interested in the origins of quantized spin for particles, and also the origin of fermions versus bosons. And we've made some progress. I think we have a good qualitative idea about how that works. And it's just a bunch of heavy lifting mathematical physics to really nail that down. And I think both Jonathan and I have been distracted by different kinds of particular projects. Arguably mine are well, I don't know whether mine are less relevant or more relevant, but they're different at least.